In 1980, student scores on the SAT math test were normally distributed with a mean of 537 and a standard deviation of 210.1. Marcelo was informed that he scored in the 84th percentile. What was Marcelo's score on the SAT math test? Okay, so we have all the information we need here. We are told that we are dealing with a normal distribution. The scores for this SAT test are normally distributed. The mean is 537. The standard deviation is 210.1. Okay, so the scores are normally distributed with a mean of 537 and a standard deviation of 210.1. All right. We want to know what Marcelo's score on the SAT math test was, and we are told that he scored in the 84th percentile. So remember what the 84th percentile means. That means it is the score that's larger than 84% of the scores. So since we're dealing with a normal distribution here, normal distribution with a mean of 537, we want to find the score somewhere over here, some mystery score, so that it is larger than 84%. Okay, we want this here to be equal to 84% or 0.84. Okay, we want to find this mystery score. So another way to say this is the probability that x is less than this mystery score is 0.84. Okay, if we just pick someone at random who took this SAT test, 84% of them will have scored less than Marcelo's score. Okay? Okay, so how do we go about finding that? Well, we're told what the probability is. We need to find the particular x value, right? So we are told the probability. We need to find the particular x value, which will be Marcelo's score. So to do that, we first need to find our z-score, which converts the problem to a standard normal distribution. We're going to do that with the q-norm function. So the probability we plug in should be a probability in the lower tail of the distribution. In this case, that's exactly what we're dealing with, right? This probability here, that 0.84, that is the probability in the lower tail or the left tail of the distribution. That's the tail that we have shaded. Okay, so we don't have to change anything. It's just 0.84. We don't have to do anything fancy. So that's going to be our z-score, and I'm going to store the result in a variable which I'll call z. So that's the z-score. That means that 0.84, in terms of my standard normal distribution, the probability that z is less than 0.9944579 is 0.84. So that we found the value for the standard normal distribution. That's what that z-score is. But now we need to convert that from the standard normal distribution to our non-standard normal distribution, the distribution of the actual SAT math test scores. And we do that using the formula x equals the mean plus z times the standard deviation. Okay? So x equals the mean, which is 537, plus the z-score, which I can either write 0.9944579, or because I chose to store that in variable z, I called that value z already, I could just write z. And it's a little simpler to write. So 537 plus my z-score times my standard deviation, which is 210.1. And that's going to give me Marcelo's score. So his actual score was 745.9356. And so that's the probability that's the value, 745.9356, so that the probability that a random score is less than that is 0.84. That is, this is the 84th percentile of the SAT math scores.